What a great day! Let's solve the linear equation on number 9. X plus y plus z is equal to 1. Choosing y and z to be free variables, let y be s and z be t, where s and t are any real numbers, so we have x plus s plus t is equal to 1. Using additive inverse of negative s and negative t, we can describe the solution set as x is equal to 1 minus s minus t. And that is my solution for number 9. Thank you. For number 81, we need to determine the value or values of k such that the system of linear equation has exactly one solution. And we have x plus ky is equal to 0 and kx plus y is equal to 0. First thing to do is we need to reduce the system to row echelon form, and for that, we need to focus on coefficients of the equations. We only have two variables, and that is x and y. The coefficient of x is 1, and the coefficient of y is k in our first equation. And in our second equation, the coefficient of x is k, and the coefficient of y is 1. Now, to reduce the system to row echelon form, this k must be 0. And for that, we need to think a formula that can change this k into 0. And that is negative k times row 1 plus row 2. Let's apply it in our first column. Negative k times row 1 or 1 plus row 2, and that is k, is equal to negative k plus k, and that is 0. Of course, we need to apply that also in all of the columns, so negative k times k plus 1 is equal to 1 minus k squared. Now, we need to put it back into equation. Again, this column is for x and this column is for y. And this row or the first row is the first equation and the second row is the second equation. So, on our first equation, we have 1x or simply x plus ky is equal to 0. And in our second equation, we don't have any x, so we only have y, and that is 1 minus k squared times y is equal to 0. Now, our main goal is to have exactly one solution. But, observe the second equation. Is it possible to have no solution or many solutions? Yes. If that 1 minus k squared becomes 0, then definitely it is 0 equals to 0. And that is no solution. We need to avoid that. So, we need to put some rules. That is 1 minus k squared must not be equal to 0. And to be more specific, we need to get the value of k. So, we can simply factor it out, or we can use that equation directly to get the value of k. So, 1 minus k squared is not equal to 0, okay? Using additive inverse of positive k squared, we can get k squared is not equal to 1. Simply get the square root of both sides, and we can get k is not equal to positive or negative 1. So, the rules are, the value of k is an element of real numbers, and k is not equal to positive or negative 1. Now, we have y is equal to 0 on our second equation. Let's apply it to the first one. x plus ky is equal to 0. So substitute the value of y. X plus k times 0 is equal to 0, or simply x is equal to 0. So the unique or one solution for the given system, x is equal to 0 and y is equal to 0. And that is my solution for number 81. I'm Algebra from BS Ed Math 2B. Thank you.